Hello, everyone. This is Mr. Bryce with Susquehanna Valley High School here in Concord, New York. We're doing Unit 2, Lesson 5, a one-to-one function, Common Core Algebra 2, the non-Regents version. Hey, if you don't understand what I'm saying, just scan that QR code and you'll listen to the genius that made these worksheets. We are really going to love this one. It's one-to-one functions. Functions, as a rule, can be divided into various categories based on characteristics that they share. One category is comprised of functions known as one-to-one. The following exercise will illustrate the difference between a function that is one-to-one and one that is not one-to-one. Okay, exercise 1. Consider the two simple functions given by the equations f of x equals 2x, linear, and g of x equals x squared, quadratic, parabolic. Map. That means put it down. Map the domain, -2, 0, 2. Using each function, fill in the range shown by the mapping arrows. Okay, so let me see. The first one, f of x. This is f. Okay, and it's 2x. So let me see. -2 times 2. -4. 0 times 2. 0. 2 times 2. 4. Okay. This seems pretty easy. G of x is x squared. -2 times itself. -2 squared is 4. Okay, 0 squared is 0. 2 squared is 4. Wait a minute. What did you just do, Mr. Bryce? Did you see that? -2 goes to 4. 2 goes to 4. You don't write numbers more than once inside the range. The range is just 4 and 0. You don't duplicate range. -4, 0, +4. What is fundamentally different between the two functions in terms of how the elements of this domain get mapped to the elements in the range? For every number in the domain, there's only one number in the range, and back and forth. For every number in the range, there's only one number in the domain. For one number in the range, there's only one number in the domain. 1-to-1. So think of it this way. A one-to-one function. Function f of x is called one-to-one if we have two unique inputs. We're putting in two unique numbers. The first number does not equal the second number. We're putting in two unique numbers. That implies, since it's one-to-one, that the answers are going to be unique also. They're not equal to each other. They're not equal to each other, okay? So if the x's don't equal, the y's cannot equal each other. In other words, different inputs give different outputs. Okay, now let's try to relate this to your life. In the dating relationship, you're dating someone. If you have a one-to-one relationship, doesn't mean that all relationships are one-to-one. I'm just saying that when you have a one-to-one relationship, you're engaged. That's a one-to-one relationship. That means that you are dating one person and one person only, and that person is only dating you, one-to-one. That's what the engagement ring represents. Exercise 2. Of the 4 tables below, one represents a relationship where y is one-to-one function. The others are not. Explain why they are not. No. Four goes to 2 and -2. Let me see. -2, -1, 0, 1. So far, so good. 1, 0, 1, 2. No. -2 goes to 1 and 0 goes to 1. Can't happen for one-to-one. 1, 2, 3, 4, 2, 4, 8, 16. Of the 4 tables below, one represents relationship where y is one-to-one function. That would determine which is yes. Okay. And why the others are not. 3, 2, -3, -2, -1, -2. Uh-oh. Those numbers better be the same. Nope, 9 is not the same as 10. No, -2 goes to 9 and 10. It's not 1 to 1. Let's see what's on the next page. Exercise 3. Consider the following 4 graphs which shows a relationship, graphs which show a relationship between variables x and y. Okay, so these are relationships. Doesn't say they're functions, just says they're relationships. Circle the 2 graphs above that are functions. Okay, let's start with this one. Is this one a function? No, fails the vertical line test. No. For every x, there is sometimes 2 y's. Right there, fails the vertical line test. Same as number 2. No matter what I do, oh, sorry, they're connected. So no matter what I do with a vertical line, it only hits the curve at one spot. No matter what I do with a vertical line, it only hits the curve at one spot. Circle 2 graphs above their functions. Explain how you know. Number 1 and number 4. You can say for every x there's only one y, but I'm going to just say pass the vertical line test. Okay, of the 2 graphs that we just circled, which this function is 1 to 1? For every x there's one y, and for every y there's one x. Well, I'm going to say it's number 4, because also for every y there is only one x. For every x there's one y, for every y there's one x. Okay, that's what a one-to-one function means. If any given horizontal line passes through the graph of a function more than one time, that function is, wait. Okay, I was looking for the word not, but this says if any given horizontal line passes through the graph of a function at most one time, that means it can only go through once. There we go. This test works because the horizontal line represents the constant y values. If a horizontal line intersects the graph more than once, an output has been repeated. This is a horizontal line test. So I'm highlighting that. And it says, if that happens, if a horizontal line intersects the graph more than once, then output has been repeated. And it's not a 1-to-1 function. Which of the following represents the graph of a 1-to-1 function? Let me see. It passes the horizontal line test, but fails the vertical line test. So it might be 1-to-1, but it's not a function. It's not 1-to-1. Has to be a function. No. Passes the vertical line test, fails the horizontal line test. Fails horizontal line test. Fails vertical line test. Ding, 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 ding. Fails horizontal line test. Exercise 5. The distance that a number x lies from the number 5 on a one-dimensional number line is given by the absolute value. Oh, okay. Show by example that d of x is not 1-to-1. Let me see. I got to think of 2 outputs. So let me see. Do you remember from algebra in 9th grade, which way does the function shift? If I plug in 5, 1, 2, 3, 4, 5, the answer is going to be 0. If I plug in 4, 4 minus 5 equals negative 1 equals 1. And if I plug in, let's say 6, 6 minus 5 equals 1, and the absolute value of 1 is 1. There we go. So there's an example. Remember that? Function shifts to the right 5. Hey, we're done. And it's right around 10 minutes. Bingo, bango, bongo. If you have any questions, ask me in class. See ya!